Hi everyone, welcome back. And today we'll solve a problem in DFA, or we'll design a machine with DFA. Okay, so the problem is that I have taken an alphabet 0 and 1, and I wanted to make a problem, or I wanted to design a machine such a way that it accepts the string 0 0, two consecutive zeros it should accept. Okay, so the like here are the sample words. Here are the sample words that I have taken. Like the words can be like 0 0 0, or it can be like this, or it can be even like this, or it can be, it cannot be like this, it cannot be like this, or it can be like this. Okay, so these are all some sample words that it likely to have, or are finite automata, deterministic finite automata likely to accept. So we have to design a machine like that. Okay, so now we'll take this 0 0. Initially we'll have to work with this minimum thing. So we'll start with the state 0, and for 0 it should move to another state called 1, and for, because I should minimum guarantee this two zeros, right? When I say consecutive zeros, this two zeros are consecutive zeros, consecutive two zeros. So this string I'll make. Okay, so when this is of the thing, like this should your automata should accept, right? So if we have 0 0, your machine accepts. But is that the only case? No, right? We might even have 0 0 0. Okay, here also you have two consecutive zeros. So now what happens is, like when these two zeros are processed, we don't forget, we don't bother about the 0, right? So my two zeros are satisfied over here. So I'll make a self loop here. Okay, so when you make this first 0, second 0, you have come to the final state. When you process this third 0, we have already seen in the previous example or previous lectures that we can say a word is accepted only when you reach the when you complete processing this input. So soon after coming this, you will reach this final state, but you cannot tell the string is accepted. When you process this, it stays in the same state, and this is the final state as well. So this string is accepted. What about this one? What about this one? Okay, I have this satisfied. I have this double zero satisfied. So what we will do is we'll add one over here. Okay, see, remember, from a state on 1, it should not be like this on a DFA. From state 1, taking 1, it can move to state 2 and 3 as well. So this is when you design like this is the NFA. Okay, however, like from state 1, you can take either 0 or 1, and you can move to another state called 2. Okay, this is DFA. However, this is NFA, because upon taking a same input from the single state, it moves to either 2 or 3. Okay, so this is NFA. Now this is not our topic of interest, so this is our topic of interest. So I made from the current input, it takes either 0 or 1, stays in the same state. So this is getting satisfied. What if I have 0 1 0 0? This is also to be accepted, right? So we'll little change this one. From this 0, upon 0 it will come here. After this, if you give 1 0, it should move to the final state. After that, when you give any number of zeros, any number of ones, it is of that sort. It is accepted. But in between, if you give 1, it is like this. This pattern, it is not the correct pattern that we want, right? This is the pattern that we want. So after this 0, here if you are giving 1, let us make like this. So after 0, if you give 1, it will go to 0. It will go to this state 0. And if you give 2 1s alone, because I need this consecutive 2 zeros, right? So if you give 2 zeros, it will come here. Understand? So if you give 2 zeros, it will come here. Or what if I do whatever you did here, you can make it here. Okay, so I just made a self loop. So any number of 0 that you give, it will be in the start state only. The moment you give 0, it will come here. The moment you give 2, it will come here. At second 0, it will come here. It is in the accepting state. So this pattern getting accepted. So this is the way to design an finite automata. Okay, so we'll make one transition table out of it. Del, and states are 0, 1 and 2, and we have input symbols called 0 and 1. From 0, when you give 0, it will move to 1. From 0, if you give 1, it stays in the same state called 0. So it is in the state called 0. Or okay, from 1, if you give 0, it will move to 2. From 1, if you give 0, it will move to stage called 2. From 1, if you give 1, it will go back to 0. Okay, and from 2, if you give 0, it will stay here. If you give 1, it will stay here. So if you give 0, it will stay here. If you give 1, it will stay here. Okay, and you understand this? Now we'll see like how to trace this input. Okay, let me take this and let me teach you how to trace this. Okay, there's one informal method of checking this. I'll start with the state called Q. For simplicity, now I'll make it as Q0, Q1 and Q2. So this is Q0, Q1 and this becomes Q2. And now this is the start state, so make, and this is the final state, so make this a string, and this is what your state transition table. So I'll start with Q0 and my input string is 0, 1, 0, right? So 0, 1, 0. I'll start with the state, and now from Q0, if you give 0, you will be moving to, from Q0 on 0, you will be moving to Q1, and from Q1, if you give 0, you will move to, your second input is 1. So upon giving 1, you will be moving to, from Q0 1, again Q0. Okay, so Q0. And from Q0, if you give 0, the second input, the current input that we need to process is 0. So from Q0, when you give 0, you will be moving to Q1. So I'm moving to Q1. So from Q1, and my current input is 0. So from Q1, if you give 0, you will be moving to Q2. Okay, so this is the informal method of tracing any input. Say any part of your problem solving, you want to solve this, you can use this method. But when that is the question, if finite state machine is given like this, and you want to check whether this machine accepts this string, you can't do this because if this question is for 2 marks, you can very well do this and tell the answer. If the question is for 4 marks or more than that, you need to go for the formal method of doing this. So you have to do this like, okay, Q0, and whatever I want to do, this is 0, 1, 0. So take this as the input, and first you have to process Q0 on 0. When you do this Q0 on 0, your output state is Q0 on 0, your output state is Q1. Okay, and Q1 on 0, 1. Okay, for this what I allow to do is del of, I have done this del of Q0 on 0, right? So I will do like this, del of Q0 comma 0 of this 1. Okay, so because I this is the cumulative step of first and second input, cumulative sum of first and second input. First input I have already processed, so I'll just brought in this one here. Okay, like I have just replaced what I have to do to process Q0 on 0 comma 1. I have to first check this, and from this I have to check this, no? This output, from this output I have to apply 1. So I am replacing this and adding 1 here. So now what is Q0 on 0? Q0 on 0 we have already found it is Q1. So Q1. Now this becomes del of Q1 comma 1. What is del of Q1 comma 1? Del of Q1 on 1 is Q0. So your output is Q0 here. Now del of, what is your next input? 0. Del of q naught comma 0 comma 1 comma 0. Now how will you do? Now again we can write now del of q naught comma the first 0 comma 1 comma 0. You understand, right? Now this we have already found and the output is q naught. Now I'll add del of q naught comma the output is q naught comma 0. So I mean the output is q naught, so I'll apply q naught comma 0 here. Now what is q naught on 0? Q naught on 0 is q1. So your output is q1. Now del of, here I am just adding the other one, don't confuse that output here. So q naught comma 0 1 0, the one element which is left is 0, so add that 0 1 0 0. Now del of, I can replace that right, q naught comma 0 1 0. What is your current input? It is 0. So what is the output of this part? q1. So q1. Now I'll make del of q1 comma 0. What is del of q1 comma 0? From q1, when you give 0, it will move to q2. You can even check here. From q2, if you give 0, it will move to, sorry, from q1, if you give 0, it will move to q2. From q1, if you give 0, it will move to q2, where now your output is q2. Now check del of q naught comma 0 1 0 0 intersect of f. What is your f? It is q2. So when you make this intersection, what is the output of this? This output is nothing but q2. q2 intersection of q2 becomes q2, which is the accepting state. Okay, so this is like when you do this for DFA, it looks simple, but when you do it for NFA, you will get multiple states, because from one state it can go to multiple states, right? So you will get multiple states here. So by that time, when you intersect with the final state, and you will also have multiple final states. So when you make this interception, if you get some state from the final state, you can tell that string is accepted. So this is what the formal method of doing this. Okay, thank you. We'll see in another lecture.